Hello and welcome to the AdNug podcast, the podcast for the Adelaide.net user group. I'm your host, David Gardner. This is a recording from our August 2023 meeting, Managing Granular Authorisation in .NET with Ryan Rowston. And now, over to the presentation.
Welcome everyone, thanks for coming. I'm here to talk to you about how we're managing our granular authorization in our .NET APIs and in web apps. So, the part that I probably hate the most about presenting, who am I? I'm Ryan Rowston. I'm a software developer at Tap2. A bunch of my colleagues have come. Thank you very much for coming along. And I like making cool codes. Who are we? So, Tap2, place where I work, is basically a small boutique IT company in Adelaide. We do digital leadership, custom software development, that's me, application security, and human-centered design. And we also have our sister company, Headful of Heart, which is our connection to graduates to help connect any students who are looking for a career with the industry. So, a bit of background on what I'm talking about. Authentication and authorization are concepts that are kind of everywhere in modern software. Pretty much every piece of software that you'll need to use on the internet will require at least authentication, almost certainly both. So, auth. There's the two main halves of it. Authentication is telling who you are. That's where you go into some sort of service, be it an Azure Active Directory, a Auth0, Google does it, login with Facebook does it. There's a myriad of providers for authentication, and the entire purpose of this is to determine who you are to a website. Generally, this is done through a JWT, a JSON Web Token. The other half of the coin is authorization. Once you know who someone is, you need to be able to tell if they're supposed to actually do something. So it can be a great system. I can tell exactly who you are and still let you do whatever you feel like if there's no authorization controls in place. And so you see that authorization is everywhere. I've worked on software for startups. I've worked on software for small businesses. I've worked on software for government. I've worked on software that targets internal users within the organization. I've worked on software that targets external users outside of an organization, be it broad other orgs or just general multi-tenants applications. All of it has required some form of authorization to control who can access what in these systems. So, over the course of many projects, we've evolved a bit of a pattern for how we handle our authorization that can catch a lot of the requirements that we've come across. Every project has added something new to the pattern, be it an extra requirement that needs to now adjust to, an extra feature that we've managed to innovate on, or just a bit of a spanner in the works. Every future project will add something else to this pattern, and so this isn't the end game. It's going to keep evolving from here, and always happy for tips because we're all learning, we're all improving things like this. So, let's meet the demo app for today. Looking forward to the F5 speed improvement. This is Meet Adelaide. It's an app that's very similar to an app you probably have used called meetup.com that will handle groups and events for groups and memberships to groups and attendees to events. I have implemented a very simple authentication layer into this application, so I'll go ahead and sign in. It's going to sign me in. I'm going to sign in with my Tap2 account. Seamless thing to do. And if I go into my profile, I'll see that, oh, I have a profile. I have my name and I have my email address. So I've managed to log into the app. In the app, we have groups. You have all sorts of groups. We can create new groups. You can go into our groups. And I can create posts. I can manage memberships. I can leave the group. If I leave the group, I can rejoin the group. Very normal meetup-y stuff. We have events. I can go to events. Welcome. And I can attend events. All very basic meetup app kind of things. Now, I can log into this app, and you'll see that I can just go to a group. Oh, let's go to this test group. I may or may not have the rights to be here. I may or may not have the rights to do this. But let's just create an event for this group. Let's create a new event. And let's set it for, I don't know, now. And so I can just create an event for this group, despite the system having no idea if I should be able to or not. And that's because there's no authorization here. Everything is just open to any logged in user who happens to be authenticated. That is not optimal. So let me show you the code and give you a brief rundown of how this is structured. Under the hood, we have a database. This is built just using Entity Framework for a quick and easy demo database. In our database, we store events. There are events for groups. We store groups. We store posts that go into groups. We store users. And we have two tables that say group members, which is who's a member of what group, and user events, which is who's attending what events. Very simple little data model. The application itself is built using Razor pages. So our pages, we have our home page, we have groups pages, and then sub-pages for events and posts within our groups pages. Nothing revolutionary. The data, I've written some simple abstractions for accessing the database in a repository pattern. The part that's probably most interesting to this talk is the authentication. I've used a very simple authentication here that I simply use the Add Microsoft Identity UI extensions to enable the login, logout functionality. And I've just added a base authorization to it so that I can actually catch people trying to sign in. This involves a couple of key abstractions for telling who the current user is. I've created a current identity service that will get me an object ID and the current user information. .NET's very nice with the authentication and authorization stacks in that it will I can use a HTTP context accessor to just get the user from the HTTP context. I can get the user claims, and so the claim I'm using to identify a user, because I'm using Sign with Microsoft, is the object identifier. That's the unique identifier that Microsoft uses to identify every one of your individual Microsoft accounts that you have with them. So what I'm doing is I'm just accessing the claims and getting the claims of object ID. So claim constants, object ID, that is a inbuilt class into the authentication library. To get object ID out, then the second abstraction will take that object ID and just access the database to get the user profile information that is stored in the database. In this case, you'll see the tables that the users I have are me, my Tap2 account, me, my personal Gmail-based account, but it's still a Microsoft account, it's the one I use to sign into this machine, and a separate dev account, which is where the app registration lives. The other half of authentication is app registrations. I'm not going to go deep into app registrations today because that's not the point. The point's authorization, not authentication. So that's the app. And it's a bit lacking. We need to add some controls into this. So let's hop back into our slides. We need to add some permissions, and we want to be able to control who can access what parts of the system. Not just, is this user an admin and can do things or not? We want to say, this user can create events, this user can create posts, this user can moderate posts, but not necessarily all of those things. So we don't want to use something as simple as an isAdmin flag in that user table. There's a bunch of approaches we could take for this authorization. We could tie in with our authentication provider and have our authentication provider provide us some sort of claims in the authentication token. That is a form of authorization, and that's a very valid approach to doing it. The general pattern we're going with and have been going with for a while, just because it gives us much better control, is we have the identifier of the user, in this case object identifier, and then we store our authorization information in our own database that we control. So in that database, we could store our permissions in any way. We could store the isAdmin bit, we could store a bunch of strings. We could use whatever pattern we want. The pattern we're going with is to encode this permission level into bits using a flags enum. How do you encode permissions using bits? Suppose that we had a very simple 1-byte number, 8 bits. I can assign each one of these bits a permission level. So bit 1, well, bit 0, if we start counting from 0, because that's actually easier to work with. Bit 0 is read of some noun in the system. Bit 1 is write of some noun in the system. Bit 3 could be create of some noun in the system. Bit 4 could be delete. And so that gives you a very simple CRUD mapping of permissions onto a nibble, so half a byte. Then you can use the other half of the byte for the next object. Or you don't even have to wed yourself to CRUD. You could use whatever permission makes sense for your use case on each of these bits. They are completely independent of each other. Cool, so we can encode permissions on the bits. Now what? The way to actually validate permissions when you have a user's permission stored as a bit string is you use bitwise operators. Go figure. So suppose they require read other noun permissions in this example. We AND these two permissions together and we get a result. And we'll see that our authorization flag relies on that result equaling the required permissions. And so in this case, they have all of the required bits set. So they are authorized. Hooray, they're allowed in. Suppose they tried to edit the other noun. They require bit 5. Oh, they don't have that bit. So when we AND these together, 0 and 1 ANDs to 0, and so our result does not match our required permission. And so we can say the user's not allowed in. And we can do this for any combination of required permissions. We could say the user requires read and edit of a thing to be able to do this operation. In this instance, they have the read and edit bits. We AND them together, every individual bit gets ANDed, and the required permissions equals the resulting permissions. Fantastic, they're allowed in. If they had needed read and edit of our other object, we AND them together, they have one of the bits, but our result does not match our required, they're not allowed in. And so we can really quickly do permission checks in two operations, an AND and an equals. So let's apply this. Now, rather than try and actually code all this live, which will take forever, I have cheated and created a part 2. All right, so we need to attach our permissions to the user record somehow. So to do this, I've created a new field in the user table. Permission level. But what's that permission level? Oh, the updates come through. That permission level is a flags enum. So I'm using a long, so a 64-bit integer, as the underlying data type for this enumerable. And I'm using the flags attribute to tell .NET, essentially, that this actually is encoding things at a bit level. So each one of these permissions is actually about what bits are set, not this is enumerable item 1, this is enumerable item 2, this is enumerable item 3. It is 1 or 2 is 3. And so I've defined some basic permissions here. I've set a helper method, authenticated, equals 0. Because 0 in this instance is the user has a user record, but their permission level is 0. And so if I do a check of if the user permission equals authenticated, it's just a quality of life. Then I'm defining all of these other bits in shorthand by defining 1, which is the first bit set, and shifting it over the appropriate number of spaces. So for bit 0, I don't shift it at all. I shift it 0 spaces. For bit 1, I have to shift it 1 space over, and so on and so forth. And so now I can define all my blocks of permissions. So I have read, edit, and group details, as well as delete groups, corresponding bits. Read, edit, group events are another block of 4 bits. You'll notice I've left bit 3 blank. That's to allow for a future expansion where I want to add a permission bit over creating groups to restrict that, for instance. But you never know what scenarios you're going to encounter in future. I strongly recommend, if you use this pattern, leave yourself some breathing room for change. Because shuffling these after you've gone live sucks. All right, block of 4 for group posts, block of 4 for group membership. Cool, that's all the group permissions. I've left a really big gap between the next class of permissions, which is user permissions. I can read all user details, and I can edit user details. And then a second pair of bits for reading of user permissions and editing of user permissions. Cool, I've set some permission levels. But there's still more. So what these next parts are derived roles. So I'm using the bitwise OR operation, which will OR the two long values essentially together to create a new value. So for instance, group read is having the read group details bit, the read group events bit, and the read group members bit. And I can combine these in any pattern I want, and I can continue to combine them further on. So I have group edit, so I have a basic edit level containing 4 of the edit bits, but I've said, I think advanced edit is a slightly more privileged role that allows for some really extra operations. And so I can define a group advanced edit as all of the bits in of group edit, so that's all of those bits, ORed together with being able to cancel events and delete posts. That's just a higher level operation. Then I can also define a simple group administrate, which is an even higher level of permission on groups, where I get all of the read bits, because administrators can do everything to a group, all the read bits, all of the advanced edit bits, which contains all of the edit bits, and the ability to delete the group. Only a group admin gets that particular thing in their role. And these can be used very conveniently with a abstraction in an interface to say, assign user group administrate permissions, so you can just assign the user group administrate, rather than have to say, cool, I'm going to assign this bit, 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 to make that happen. And you can combine these in any way, shape, or form to create whatever combination of permissions you want. All right, let me just apply my database update, because I have added a column to the user table. I actually need to go and apply that. So let me just really quickly. .NET EF database updates. Let me just update the database. So this will work. I am in the right folder. Cool. Let me just check. I am in the right directory. I might need to re-add the migration. This is something I always get wrong. Thank you. There we go. So now it should have added a permission column there. If I refresh the users, why? All right, let me just reset this one. Open in terminal. Oh, I know why. Pardon me a second. There we go. Now if I refresh, there we go. We have a permission level column. Oop. Reopen it. All right, I can sign in now. Sign in as tab 2 again. And if I view my profile, I'll see, cool, I'm still there. I've given my ID as a convenience here. But I don't actually have any permissions. No one's been assigned any permissions. So if I go and look at the users table, we don't have anyone with any permissions to do anything yet. We need a first person that can actually update everyone else's permissions. So we need our first administrator, which means I need to get myself as an admin. Let me go and edit that and get myself permissions. What permissions should I grant myself? So we have abstracted this into a bit string. This doesn't really easily convert back to decimal for us. Let me just find permissions again. The way to do this, and I'm happy if take suggestions if you found a better way, but the humble Windows calculator in programmer mode. You can do that. The way I tend to do it is I will go in here. Let me just do that. And I'll see that I need to set permission bits individually. So in programmer mode, you can switch in here. So you can just use long.max value, which will absolutely work. Be careful of signed. If you're using the last bit, things can get weird because databases don't always respect signed bits, or like you can't always use an unsigned long here because some other part of the system somewhere in the chain will not treat it. Be wary of the last bit if you're doing anything other than basic bitwise operations. And max value will not include that last bit. You actually need min value if you have the last bit, I believe. Either that or -1. I don't actually remember which way around that goes. Not important at the moment. So I'm going to create a permission level. I have bits 0, 1, and 2 set, 4, 5, and 6 set, 8, 9, and 10 set, 12 and 13 set. And, for these permissions, I need to go up to bit 32 and 33. I'll set bit 32 and 33, and 34 and 35. And that allows me to create, using just calculator, any permission level I want. So I happen to have created max permissions here, which is global admin, which I'm just going to cheat and copy this one because I don't want to strip out commas. And I'm just going to go ahead and grant myself that permission level. But if you're using this pattern and you want to generate yourself a permission level, that's your tool. So now I've granted myself permissions. If I go back into the app and refresh here, I'll see a button's appeared. I've actually done some tricks to show and hide that only if you have permissions to do the operation, which is an extra step. So I've got a permissions page where I can adjust the permissions for me. But authorization demo is not particularly great unless you have a second account. Let me just go ahead and log into this. And I'll just go ahead and sign in. So this is my home account, not my Tab2 account. And if I go into view profile, I'll see I don't have that permission. So what I'm going to do is I'm going to get my ID out of this, and I'm going to go and cheat a little bit, and I'm going to go and give my other user a few permissions to work with. So I'm going to give him, let's say he can edit groups and read groups. So now he can read and edit all groups. So I go in here, and if I go edit, I can edit the group. But suppose I want to go make a post. Let's just skip that for the moment. I'm denied because I've actually added a attribute which denies access to this endpoint if you don't have the appropriate authorization bit. Suppose I wanted to try and create an event. It's not blocking me. That's concerning, isn't it? So I can go ahead and try and create an event. Event, description, right here, right now. So I can create an event still. We need to add an authorization header to it. So what I'm going to do is I'm going to go and I'm going to go to find my page where the users can create an event. And events create page, that looks about right. And I'll see there's nothing here. So what I'm going to need to do, and I'll show you how this works after I show you what it's doing, after I show you what you do for here, I'm just going to really quickly cheat and take this off the group update. Where is it? Maybe one of these. All right, I'll do it from scratch. Security. Authorize for global permission level. Yep. Okay, so the create page. Authorize for global permission level. Now that's going to yell at me because I don't have the right includes. And so I'm going to say, to access this page, you need permission level create. There's actually no permission level for create group events at the moment. Edit group events to be able to create events. And if I go ahead and just make this bigger, I'll see that I've now added an attribute to the controller, same as you'd add an authorize attribute. But this has a few extra little bits to it. So now if I reboot, go back to my Ryan Rowston home account, the one that's not privileged, see your groups, test group, try and create an event. It'll take me here, which I'll skip for the moment. And it still lets me. This is the problem with live demos, isn't it? Yep, I know why. Edit group events. Bear with me a second. So name edit group events. Step into permission level, group read or group edit. Turning false. All right, let's take you on the debugging journey to show you how the auth stack works through here. And then we'll figure out where it's going awry. So, the way this works is we have the authorize attribute. That's the thing I've applied to the Razor page model. That supplies a permission level. .NET policies are ultimately strings at the end of the day. And so by setting this attribute, I have to then set the policy because I'm extending the authorize attribute. And so I make the policy equal to permission level toStringed. And so in this case, that will return the string edit group events. What happens when I submit that policy? I could, in the startup, define a policy called edit group events. And in that policy, I could set all the bits needed to check whether the user has the appropriate access and make that work. Problem is, a user can have any number of combinations here. A user could have edit group events and read group events, which is a different string. A user could have, a role could require edit group events and sing karaoke. It could have edit group events and update user details. You could have any combination of bits. And if you were to enumerate every possible combination of bits in a 64-bit integer in your startup, your file wouldn't load because that's an absurd number of permissions. It's in 64.max value different permissions. So we can't do that. So we're getting a policy that's a string. And so we need some way of transforming that policy into a permission requirement. Introducing extended policy providers. So what you can do in .NET is you can actually extend the default authorization policy provider. What this lets you do is it lets you override the getPolicy async function that's called in the middleware stack when .NET's authenticating and authorizing your request. When this function is called, you get passed that policy name. So in our case, the policy name we're looking for is edit group events. The first thing you should do when overriding it is call the base, because you're not going to necessarily own every policy in the system. There could be normal policies in there that aren't to do with your fancy enums or authorizations. So you call the base and you see what that gets you first. If the base, however, doesn't get you a result, now we're in business. So what we have to do, what I choose to do as a step 0, cool. The policy is not there, so it's some sort of unknown policy. I'll default it to the highest level of permissions required at the get-go. So I default it to admin. You need full admin to be able to do anything. And I'm going to reduce it from there. I try and parse that policy name back out to my enum, so my output permission level. If the parsing is successful, that means that, cool, the policy is valid in a pattern I understand. So then I build a new policy using an authorization policy builder. I require that the user is authenticated. They need to be logged in to be able to do this, because otherwise I can't authorize you. And I add an extra requirement. I've called this a global permission requirement. And it's because you have global permissions to the app to do something. And build that policy. Then I cheekily add that to the policy dictionary, so that next time you call this, you don't have to regenerate the policy. The base call will return that policy. And then I return the policy that I've just created. So that generates our policy. And that creates this requirement, this global permission requirement. Not a particularly complicated class, the requirements. Then we have our handler. So we can create a custom handler for authorization that handles the specific requirement. So in this case, I've created an authorization handler that handles the global permission requirements. I'm injecting my convenient little permission service, the current identity service here. And I'm using that to check if the current user has permission level. So this is a new abstraction function. So remember previously we had object ID and just get current user information. I've added a third function. What this one does is it tries to get the current user. If the current user is not there, it's false. If I can't find the user, they don't have any permissions. They're not even authorized. They don't exist in the system. But if I get the user, I get the user's permission level. And then I check if they have a flag, has flag permission. And what that's doing is that's checking essentially those AND operations from earlier. Does the user have all of these bits set? And what I'm going to do is I'm going to really quickly, for debugging purposes, we'll define that out. Return results. Restart this, because once you've done a policy once, it'll actually cache. So you don't actually see the policy generation. So back to my home account. I'm trying to access view profile page. And so this is actually doing a check to show or hide that button. And so I'll see that this is requesting the permission level read user permissions. And it's returning false because I don't have that permission bit set. And so I don't see the extra buttons. All right, so now I'm going to go through our test case. I'm going to try and attempt to create an event. Cool. Policy is that, so I'm now in my policy provider. That policy name that I'm trying to get is edit group events, as expected. I try and parse that enum out, and I get the enum edit group events. Looking good so far. Now I'm going to add a new policy. And I'm just going to step over that and show you what that policy looks like. Hopefully that's readable from in the back and online. And so I'll see I have the policy with two requirements. First requirement is deny anonymous, or you have to be logged in. That's the deny anonymous. That's what that first part there is, the require authenticated user. The second requirement is my global permission requirement with permission level, edit group events. So I've set the policy to say you need to be able to edit group events. Even if you're not using bit level permissions, being able to create your own custom policies and build them on the fly can still be very useful. All right, add the policy, move on with our lives. So now I'm in the handle requirement. I've got a requirement, So next step in the middleware stack, we've got our permission requirements. Now we need to try and actually see if the user is authorized. So I get my requirement that is the same, is the edit group events requirement. I'm going to step into this. The current user has permission level async. So I'll see my permission is edit group events. User permission level, I have group read and group edit permissions. Doesn't sound sufficient to me. And so when I try and check that has the flag, returns true. Why? This is the part that's weird. Events. Nope, that's correct. Sorry? Oh, I think I know what you're saying. So my current permissions. Permission level is group read and group edit. Thank you. I have assigned myself too much permissions. Okay, so it's doing exactly what it's supposed to do. That figures. All right, so now if I go and revoke those permissions, because I've clearly given myself too much permission here, I'm just going to remove my breakpoints so it stops doing that. And I'm just going to go ahead and I'm going to say back to my user 3, my home user. Yep. Oh, I used the presets. I'm going to revoke those permissions. So now I don't have the ability to do that anymore. Better. If I view the permissions again, yep, they're still gone. Go in as my home user, go back to the group, now try to create an event. If I step in here, this time, I'll see that my current permission level is not edit groups, it's not the abstraction, it's all of those bits that are set. Return false. And now we're cooking. Access denied. So that's the general flow.
I had a question online,
Yep.
Which was, is there any benefit to skipping bits or leaving room?
Future expansion.
Yeah.
Future expansion is the #1 benefit to it.
Yep.
So as a human, I like to group things in logical blocks. And so if, for instance, I create CRUD block 1, CRUD block 2, and put them right next to each other, what happens if someone says, suddenly, that noun, there's actually a 5th operation on it. There's a manage permissions on that noun. Suddenly you look at your very tightly bound enum and you think, oh no, I either need to put edit noun permissions as a separate bit somewhere completely separate in the enum, or I need to reshuffle all of these other bits down one, which if you've gone live, not fun. If you haven't gone live, if you're fine to just clear dev databases, not actually that bad. You just literally increase all the numbers by 1. But leaving yourself some gaps, especially if you have few enough permission levels to leave yourself some gaps with 64 bits of permissions, makes life easier down the track if there's change.
Yeah, and is the order important for a hierarchy or anything, or?
Not really. Completely, because each bit is completely separate from another bit. There is no technical importance to it. I can definitely see a human reason to group them logically together and to maybe hierarchy them. So for instance, in this one, this will probably take me to the wrong spot, but I'll just daisy chain in. You'll see that I've kept all of my group stuff logically together and all of my user stuff logically together. It's not really a hierarchy, but it's blocking of logical parts of your system. But each to their own with approaches of how you structure these. From a technical perspective, it doesn't matter. I could shuffle these numbers randomly as long as there weren't any collisions, and it would still work exactly the same, aside from the fact that I'd have to clear the database because I'm changing the permissions. I actually should break for a moment. Are there any other questions from the audience here? Yes, Luca?
Could you expand this model to handle data?
Yes, you absolutely can. That's actually the next stage of this. So yeah, as Luca pointed out, this works to a point. I have been able to grant myself permissions to edit groups. Cool. I can go and edit whichever group I choose. But suppose there were some users that came along with some requirements that says, I don't want anyone to be able to edit my groups. I want to have my group, and I want to be able to edit my own group, but I don't need to edit everyone else's groups. And I don't want every other group administrator able to edit every other group in the system. That's a recipe for trouble. And so we need some sort of row or object level permissions that says, I want to allow David to only access adnug group. I don't want to let him access the front end group unless they specifically add him to do so. There will probably still be some global administrators with that global permission level that lets them do administratory things, moderation things. The internet can be a very nasty place sometimes. Sometimes you need admins with the ability to go and do things. But let's add some object level permissions into this. Don't save that. Adelaide. And so this is a new version of it that adds in the row level permissions, that ties permissions back to, in this case, groups. So I'll show you how that works. In my models, I've added a new column. So we have the group member table. This table specifies who is basically a join table between groups and users. And it says, is this user a member of this group? I've added an extra field in here called user group permissions. This is a permission level, much the same as the permission level that we saw for the global permissions. But because this is in the join table between the group and the user, this permission level is specifying this user has this permission level on this group. And it doesn't extend beyond that. So let me just go ahead and really quickly update the database again. Open terminal. Now I've cleared the existing migrations, this should just work. Apply migration. And if I go to the database, I'll see that there's a new column in here. Group members. There's now user group permissions. And they're all defaulted 0 because I haven't granted anyone any specific access to a group yet. So let's go and do that. Let's run our app. And let's go to my admin account once more. Tab 2. I have global permissions, well, when I sign in again. Each one of these applications is actually a somewhat slightly different application, so I have to log in every time. So Let's go to my test group. And there's a new button I've added that allows me to edit a user. So let's go to my home account. And I can now set permissions for this group specifically against that user. So if I was to set create group posts and edit group posts and delete group posts, why not? He can do those three things. You're a moderator, but nothing else. And I'll go and update the permissions. And before this catches me out, I'm just going to go and remove his global permissions because that's going to get in the way of this demonstration. And I've cleared all his global permissions. No more global permissions for my home accounts. So now, if I sign in to my home account, go to my test group, I'll see that, oh, I've hidden all the buttons. I'll show you how the button hiding all works. That's just a UI trick. It doesn't actually affect any real permissions. That's the same as going to your spa and saying, check if the user has this permission level and just don't show the control. It doesn't actually change any authorization, hiding or showing buttons. But I'll see that I have posts. I have the ability to, do I have the ability to make posts? It's denied. Okay, so that means I need to go into the code and add that capability. So, to do this, we'll go into our page, groups, posts, and our create post. And I'll see that I've still got the global permission level. So currently, this page is saying no, because you require the global permission level to be able to create a post. That's not going to work. We need to adjust that to be our local permission level. So, authorize, I'm going to change this to authorize for group access with permission level of create group posts. So now I'm using a different attribute that has a completely different requirement, completely different implementation that ultimately results from it. Subtly different, I suppose I should say. So let's trace that through and see how that works. I'm just going to reboot this, and I'm going to add some breakpoints to show you how that policy is applied. Permissions, requirements, group permission handler, breakpoint here, and permission policy provider, breakpoint here. Cool. Let me go to my home account again. Go back to groups, test group. Safe. And now I'm going to try and make a post. And what I'll see is I get a policy name. My policy name is create group posts, comma. So now there's actually two parts to this permission string, this policy that I've created. And I'm using just a comma to separate. You can use whatever delimiter you want. I recommend not colon just because some scopes already use that and it can get in the way. But a comma string is a fine way of handling it. I've not had any issues using commas. The other half of it is a constant value, group permissions. So this is basically telling my code in this function that this is actually a group permissions policy, not just a global permissions policy. So if I step us through, I'll see that the policy doesn't exist. This has to be a dynamically created policy. Same as before, I'll set the policy to admin and then work backwards from there, just because if for some reason an enum parse fails, I don't want to let someone in who shouldn't be in. Fail on the disallow side. Good philosophy in general. Now I'm going to split in the string, so I get an array of my policies. 2 of them. The first one's going to be much the same, except I'm just getting the policy 0 rather than the whole policy. So the first one in that array. And if I go through here, I will see that I have an initial policy. I am working my policy backwards, and so my new policy is a global permission policy with 2 requirements. requirement 0 is deny anonymous, same as before, and requirement 1 will be permission level create group posts. So this is a global policy, global permission requirement, that you have the global role to be able to create group posts. And before we added object permissions, that's where the story ended. But now there's an extra step. I'm checking if there's a second half to the policy. If there's not a second half to the policy, the story ends there. That is, if this is a global permission requirements. But if there is a second half to the policy, as there is this case, I'm using a switch because this allows you to very easily add other type permissions. So for instance, there's group permissions, but I could add whatever other class of object level permissions I wanted by just adding an extra row here. And so you can add object level permissions for any number of things. So I'm just going to do a quick switch on that. I'll see that, oh, my policy 1 does equal my group permissions constant. Isn't that convenient? And it will create me a new policy. This is a group permission requirement rather than a global permission requirement. Not to be confused. And continue on. And so now I have a policy. So now I go to a new handler, permission handler, my group permission handler. And I've been given this group permission requirement to my new authorization handler to handle group specific. Once again, check if the user logged in. If they're not logged in, they can go away. They're not supposed to be here. So, this is the catch with using object level permissions. You've got to have a consistent way of defining how the user's addressing into that object. For this application, I'm using query parameters to always say group ID equals whatever the group ID is. And so I'm getting it out of the query parameters here. Oh, you cannot see that very well because of the line. I'm getting it out of the request query parameters to get my group ID. In other applications, I've used route parameters, which is a very similar operation. Instead of getting out of the query, you get it out of the route. And so you can get this out of anywhere in the HTTP context, but it needs to be in the same place. Otherwise, this will not work. You can check in multiple places if you really want to, but just put it in the same place. I'm going to get my group ID out and convert that to a long, because that always comes out as a string from query parameters. And I'll see that this group ID is 2. I'm checking if the group ID is real. So if the group ID is not found, I can't succeed this requirement because I can't validate against the group. So now I'm going to use a new helper function in our current identity service. There's now a new function. Current user can access group. Step 1, check if they have the permission level. If they have the global permission level, I don't care if they can or can't access that specific group. They're globally allowed to do this operation. I can just check that and then continue on. I get the user and I get their group membership. So this is getting the group member record that says what the user group permissions are. As long as that group member exists. So if the group member doesn't exist, that means this user is not even a member of this group, let alone has any extra permissions, and it is not true. They do not have access. And then I do exactly the same thing. I check against the user group permissions there, and I check has flag, create group posts. And so what we should see here is that should return true. And so the requirement will succeed because I've granted myself the object level permission to create group posts. After all that, I can go back to my browser and create a post. On the publish, because this is a separate endpoint in the same controller, it will have to revalidate that auth because I'm setting a new rope request. I have to validate it every time. And so I'll see that here I've requested policy name, create group posts. Because I've cached it in my policy thing, I'll see that I actually get the policy out of the base class for the policy provider. And so I can just return that policy outright. Makes life a bit quicker. And I'm just going to go and skip the handle requirement. because it'll let me create the post, and now I have a new post. Yay. All right. Some caveats to all of this. First of all, you have Razor Pages, you have to add it at the controller level. Well, at the page model level is how it's called in Razor Pages. You can't do it per method. In an API, you can do this per controller endpoint. And so, for instance, if I have a home page that had a bunch of buttons like edit and delete, I can delete a post straight from this page. And let me just go and do that. By post, 401, unauthorized. And the reason that that's unauthorized is that I have to actually do a manual check in that endpoint. Let me just go and quickly navigate to it. Posts. So this is on the details page for a group. And I'll see that I have an on post, delete post. Yes, it's funky, but it's the HTTP post and then the logical group post. They're just both called post. I did not think that through. And so what I have to do is I have to check if the user has permission level to delete group posts. And what I actually now need to do now that I'm object level permissions, I need to change that to be current user can access group. And that takes a group ID and pass the group ID into that. So I now need to check if the current user can access the group to be able to delete posts in that group. And if they can't, unauthorized. They're not allowed to do it. And you have to add this inside the controllers for all Razor Pages. For an API, you can add an attribute to the endpoints, the same as I've done for the whole class, and the most specific will be the requirement. So you can set read at the class level. In this case, I've used allow anonymous because we want even non-logged in people to be able to see a group. And then you can add an edit attribute on that endpoint or whatever your heart desires. Next caveats. This supports conveniently up to 64 bits. If for some reason you need more than that, the easy answer I've got for you is just use two different permission levels and find some sort of logical divide to draw the line between them, or 3, or any number. I think that's about it. I can go a bit deeper into any of the little parts. I've skipped a few bits of how this system functions, but most of it's there. I've skipped over the authorization pages, but you'll see those bits on the edit permission level. That's just iterating over the enum values to give you all those checkboxes. Nothing too fancy. All right, pizza's here. So I think that's it for things I had to talk about. Are there any questions? Mm-hmm. Okay, for the online audience, the question is essentially, I want to get a report of what permission levels can access what in my system. And so is that right? And this does kind of abstract a lot of that. I would argue that kind of any authorization system will to a degree. The one benefit of this is that you can just theoretically, I've never had to do this, theoretically you could write a regex or some sort of security scanning tool. I know there's a couple of really powerful security scanning tools